Welcome. Let us discuss about infrared spectroscopy. Infrared spectroscopy or vibrational spectroscopy is an analytical technique that takes advantage of the vibrational transitions of a molecule. It is one of the most common and widely used spectroscopic techniques employed mainly by inorganic and organic chemists due to its usefulness in determining the structures of compounds and identifying them. The method or technique of infrared spectroscopy is conducted with an instrument called an infrared spectrometer or spectrophotometer to produce an infrared spectrum. Principle of infrared spectroscopy. Infrared spectroscopy is the analysis of infrared light interacting with a molecule. The portion of the infrared region most useful for analysis of organic compounds have a wavelength range from 2500 to 16,000 nanometer, with the corresponding frequency ranging from 1.9 to 1.2 Hz. Photon energies associated with this part of the infrared from 1 to 15 kilocalories per mole are not large enough to excite electrons, but may induce vibrational excitation of covalently bonded atoms and groups. It is known that, in addition to the facile rotation of groups about single bonds, molecules experience a wide variety of vibrational motions characteristic of their component atoms. Consequently, virtually all organic compounds will absorb infrared radiation that corresponds in energy to these vibrations. Infrared spectrometers, similar in principle to other spectrometer, permit chemists to obtain absorption spectra of compounds that are a unique reflection of their molecular structure. The fundamental measurement obtained in infrared spectroscopy is an infrared spectrum, which is a plot of measured infrared intensity versus wavelength of light. Infrared spectroscopy measures the vibrations of atoms, and based on this, it is possible to determine the functional groups. Generally, stronger bonds and light atoms will vibrate at a high stretching frequency. Instrumentation of infrared spectroscopy. The main parts of the infrared spectrometer are as follows: radiation source, sample cells and sampling of substances, monochromators, detectors, recorder. Infrared radiation sources. Infrared instruments require a source of radiant energy which emits infrared radiation which must be steady, intense, enough for detection, and extend over the desired wavelength. Various sources of infrared radiations are as follows: Nernst-Glauer, incandescent lamp, mercury arc, tungsten lamp, Glauber source, nichrome wire. Sample cells and sampling of substances. Infrared spectroscopy has been used for the characterization of solid, liquid, or gas samples. Solid. Various techniques are used for preparing solid samples such as pressed pellet technique, solid run in solution, solid films, mull technique, etc. Liquid. Samples can be held using a liquid sample cell made of alkali halides. Aqueous solvents cannot be used as they will dissolve alkali halides. Only organic solvents like chloroform can be used. Gas. Sampling of gas is similar to the sampling of liquids. Monochromators. Various types of monochromators are prism, gratings, and filters. Prisms are made of potassium bromide, sodium chloride, or cesium iodide. Filters are made up of lithium fluoride, and diffraction gratings are made up of alkali halides. Detectors. Detectors like thermocouples, bolometers, thermistors, Golay cell, and pyroelectric detectors are used. Detectors are used to measure the intensity of unabsorbed infrared radiation. Recorders. Recorders are used to record the infrared spectrum. Applications of infrared spectroscopy. It has been of great significance to scientific researchers in many fields such as protein characterization, nanoscale semiconductor analysis, and space exploration, analysis of gaseous, liquid, or solid samples, identification of compounds, quantitative analysis, information regarding functional groups of molecules and constitution of molecules can be deduced from infrared spectrum to know about interaction among molecules.